I am live, and yeah, today we are going to continue what we did yesterday. That is writing our own implementation of MD5 algorithm, MD5 hash function, which is message digest 5, and we found its RFC number was 1321, and here it is, the RFC for it, and we had implemented this till this point, right? Yep, till this point. And now we have to implement the rest of this. But before that, before I implement the rest of the algorithm, I would like to continue reading this last chapter in the programming language, the C programming language in NC standard, NCC. Yep, KNR, Kernighan and Ritchie. And this chapter is, I guess, going to be fun. The Unix operating system interface, because if I were to do the advent of code problem first and then move on to reading the last chapter, I do not imagine that happening very well. But I can read this right now and then do the problem, because I will be very happy while solving the problem, and I can push myself further while solving the problem. Now, the Unix operating system the Unix operating system provides its services through a set of system calls, which are in effect functions within the operating system that may be called by the user programs. Yes, syscalls. And this chapter describes how to use some of the most important syscalls from C programming. From C programs. Shit, I can call syscalls from C. That is crazy. I thought I can only do that from assembly. If you use Unix, this should be directly helpful, for it is sometimes necessary to employ system calls for maximum efficiency or to access some facility that is not in the library. Even if you use C on a different operating system, however, you should be able to glean insight into C programs from studying these examples. Although details vary, similar code will be found on any system. Since the ANSI C library is in many cases modeled on Unix facilities, this code may help your understanding of the library as well. Okay, the ANSI C library uses the Unix facilities for its implementations, like the printf function and scanf functions, to access the standard input and output. Okay, this chapter is divided into three major parts: input output, file system, and storage allocation. The first two parts assume a modest familiarity with the external characteristics of the Unix system. Chapter 7 was concerned more with an input output interface that is uniform across operating systems. On any particular system, the routines of the standard library have to be written in terms of the facilities provided by the host system. In the next few sections, we will describe the Unix system calls for input and output and show how parts of the standard library can be implemented with them. Yep, the file descriptors. Yes, file descriptor is something that I get. Well, the only interaction that I have had with the file descriptor is when you call the syscall to read a file. Then when you do a syscall to read a file, then what you get as return is the file descriptor for that file. In Unix operating system, all input and output is done by reading or writing files. Okay, because all peripheral devices, even keyboards and screens, are files in the file system. Yes, are files in the file system. The screen that I am seeing right now is stored in a buffer somewhere, and that is being picked up by the monitor and being updated by the operating that is just, is that actually what is happening? Because that is just too simple, right? there is a file whose contents I can change, and depending on those contents, I see output on the screen. That is just very crazily simple, like everything else in a computer. If you take a lot of simple things and add more things on top of it, you get very complex, amazing things, but the underlying details are still very simple, intuitive, you could say, maybe even. This means that a single homogeneous interface handles all communication between a program and peripheral devices, just like you do in a general purpose IO device. In the most general case, before you read and write a file, you must inform the system of your intent to do so. You must inform the system of your intent to do so. A process called opening the file. If you are going to write on a file, it may also be necessary to create it or to discard its previous contents. The system checks your right to do so. Does the file exist? Do you have permission to access it? This is just so fucking amazing. And if all is well, returns to the program a small negative integer called a file descriptor. Small negative integer. Whenever input or output is to be done on the file descriptor is used instead of the name of the file to identify the file, as a file descriptor is analogous to the file pointer used by the standard library, or to the file handle of MS-DOS. All information about an open file is maintained by the system. The user program refers to the file only by the file descriptor. Since input and output involve keyboard and screens, so no common special arrangements exist to make this convention convenient. when the Since input and output involving keyboard and screen is so common, special arrangements exist to make this convenient. Okay, when the command interpreter, the shell, runs up the command interpreter, the shell. A shell is an interface to talk to the kernel. When the command interpreter, the shell, runs a program, three files are opened with file descriptor 0, 1, 2, and called the standard input, the standard output, and standard error. Okay, when the command interpreter, the shell, runs a program, three files are opened with the descriptors. Three files are opened. Okay, when the shell runs the program, three files are opened, and for those three files, the file descriptors are 0, 1, and 2. 0 means standard input, 1 means standard output, and 2 means standard error. I have three files. If a program reads 0 and writes 1 and 2, it can input and output program without worrying about opening files. Yes, the user of a program can redirect input, output to and from files with this to get the output. Yep, yep. This is to get the standard output of one file, of the file on the right, as the standard input of the file in the left. No, fucking hell, no. This is to get the contents of a file as the standard input for the program on this side. You How do you guys see me? This and this is right. Oh shit, okay. So this is to use the contents of the file on the right as the standard input for this program, and this symbol is used to use the contents of this file to save the contents of this file in this by overwriting the contents of this file. In this case, the shell changes the default arrangements for the file descriptors 0 and 1 to the file names, to the named files. Normally the file descriptor 0, file descriptor 2 remains attached to the screen, so error messages can go there. Similarly, similar observations hold for input or output associated with a pipe. In all cases, the file descriptors, the in all cases the file assignments are changed. The file assignments are changed by the shell, not by the program. Yes, this does the shell thing. The program does not know where its input come from nor where its output goes, so long as if the user as if it uses file 0 for input and 1 and 2 for output. Now I want to ask a few questions. Yes, what does opening a file and getting its file descriptor mean? Does that mean that that the contents of the file are moved to the contents of the file are moved to the RAM? Opening a file and getting its file descriptor does not mean that the entire contents of the file are moved to the RAM. What happens when you open a file but not read a file? fopen is a higher level using open or in C or fopen. In a higher level language, the OS does the following: checks permissions. The OS verifies whether the process has required permissions, read, write, and execute for file, creates a file table entry. The OS maintains an internal table called the file descriptor table for each processes, and a system-wide file that keeps track of all open files. Allocates a file descriptor, a small integer. The file descriptor is assigned to the interface to reference the open file within your process. Okay, associates a buffer, optional. The OS may allocate a small buffer in RAM for efficient reading and writing. At this point, only metadata about the file is stored in RAM, like file size, permissions, and location on disk, but the actual contents of the file remain on the disk. Okay, does opening a file load it into RAM? Nope. The contents of the file are not automatically loaded into RAM when you open it. Instead, when you read from the file, only the requested portion, a few bytes or blocks, is loaded into RAM. If the file is large, the OS caches recently accessed portions in memory for performance. If multiple processes access the same file, they might share the cached data instead of reloading it from the disk. What happens when reading a file? When you use read, the OS checks if the requested data is already in the RAM, cached in the RAM. If not, it fetches the required blocks on the disk into RAM, provides the data. Okay. So the file descriptor is just a kind of point, is just a number in a table which has on its rows other meta data about the file, but the file itself is in the hard disk. Now if another program were to open the same file, it would have another file descriptor. Since if not, then the data, the metadata, a file can be changed, can be changed. Metadata for a file can be changed in one program and will make a mess in the other. Yes, exactly. The file descriptor is just a number in the table that holds metadata about the file, which actual file remains while the actual file remains on the disk. What happens when another program opens the same file? If another program opens the same file, the OS assigns a new file descriptor to that program. Each process maintains its own file descriptor table. Each process, when another program opens the same file, the OS assigns a new file descriptor to that program. Each process maintains its own file descriptor table, so the same file can be opened multiple times by different programs or even the same program without interfering with each other. How does the OS keep track of the files? The OS maintains multiple level of tracking file descriptor per process. Each process has its own table file descriptors, mapping FD's file descriptors to open files. Okay, and system wide file table. The OS keeps a shared table that tracks open files system wide. System wide inode table or equivalent in Knox in non-Unix systems tracks attributes, permissions, and disk allocation when multiple processes open the same file. Each process gets a separate file descriptor. The OS may share some underlying file information like an inode or change made by one processor may not be immediately visible to another depending on how the cache. Yep. Okay. Yo. Yep. Uh, yep. That makes sense. Low level input output read and write. Input read, output write. Input and output uses the read and write system calls, which are accessed from C programs through two functions called read and write. For both, the first argument is a file descriptor, the second argument is a character array. Is a character array in your program where the data is to go to or to come from. The third argument is the number is the number of is the number is the number of bytes to be transferred. Int n read equals read, put in the file descriptor, number of the character buffer, and then this how many bytes I want to read. And for write, I put in the file descriptor, the string, and then the number of bytes that I want to write. Each call returns a count of the number of bytes transferred. On reading, the number of bytes returned may be less than the number requested. A return value of 0 bytes implies the end of the file. Exam and -1 implies indicates an error of some sort. For writing the return value, for writing, the return value is the number of bytes written. An error has occurred if this isn't equal to the number requested. And any number of bytes can be read or written in one cell, in one call. The most common values are 1, which means one character at a time unbuffered, and a number like 1024 or 4096 that corresponds to a physical block size on a peripheral devices. Larger sizes will be more efficient because fewer system calls will be made. Yup. Putting these facts together, we are here. Putting these facts together, we can write a simple program to copy its input to its output, the equivalent of the file copying program written for chapter 1. This program will copy anything to fucking hell. Fucking hell, that is just death. Let me get my charger. Just wait a minute. My bad. Maybe when I go away, I can make a second image, a moving image with some, or a video which I can put it on like a break screen or something. It went down to 8%. That is just absolutely crazy. Now, putting these facts together, we can write a simple program to copy its input. Yep. What do you do? We initialize a char buffer which is equal to buff size. Buff size is, I suppose, a just a number, right? And then we read from standard input in the buff how many characters, buff size characters, and then we write in the standard output buff size characters. Okay, this is calls.h. We have collected function prototypes for the system call into a file called syscalls.h, so we can include it in the programs of this chapter. The name is not standard, however. This name is not a standard, however. The parameter bus size is also defined in syscalls. Its value is a good size for the local system if the file size is not a multiple of buff size, and some read will return a small number of bytes to be written by write. The next call to read after that will return 0. It is instructive to see how read and write can be used to construct higher level routines like get char, put char, etc. For example, here is a version of get char that does not unbuffered input. It is instructive to see how read and write can be used to construct higher level routines like get char, put char, etc. Yep. For example, here is a version of get char that does unbuffered input by reading the standard input in one character at a time. Get char, initialize the char, return, read, put it in the address of the char 1. If this is equal to 0, then return this, otherwise return answering the char. If this is true, then return C, otherwise return end of file. C must be a char character because read needs a character pointer. Casting C to unsigned char in the return system eliminates any problems of sign extension. The second version of get char does input in big chunks and hands out the characters one at a time. Does not take anything in. Static character buffer. Okay, and reads size of buff buff, size of buff. Okay, buff gives in the buff, and buff pointer equals buff, right? And if n negative greater than 0, I called this a multiple times, read it in n, and buff pointer points to the last buffer. Okay, if these versions of get char if these versions of get char were to be compiled with stdio included, it would be necessary to use undef to name get char in case it is implemented as a macro. Okay, yeah. Now open, create, close, unlink, link, unlink. Yeah, that is something, right? Linking a file and unlinking a file. Other than the default standard inputs and input, output, and error, you must explicitly open files in order to read or write them. There are two system calls for this: open and seek read. Sick, like sick. Open is rather like the f open discussed in chapter 7, except that instead of returning a file pointer, it returns a file descriptor, which is just an int, which is just an integer. Open returns -1 if any errors occurred. Open, given the name of the file, then the flags, and then permissions, or the thing that you want to read. Okay, now as with f open, the name argument is a character string containing the file name. The second argument, f flags, is an integer that specifies how the file is to be read. The main values are read only, write only, read, write, for both reading and writing. These constants are defined in functional.l functional.l on system 5 Unix systems, and in sys on Berkeley BSD versions. BSD means something Berkeley related. Berkeley software department, I don't know. To open an existing file for reading, fd equals open name, read only, add 0. What is perms? Perms is 0. The perms argument is always 0 for uses of open that we will discuss. Is always 0 for the uses of f open that we will discuss. In an error to try It is an error to try to open a file that does not exist. The system call can create 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 is provided to create new files or to retrieve old ones. Create takes in a name for the file, and perms returns a file descriptor if it was not available. If it wasn't available, if it wasn't able to create the file, and -1 if not. If the file already exists, create will truncate it to 0 length, thereby discarding its previous content. It is not an error to create a file that already exists. If the file does not already exist, creates it with the permissions specified by the perms argument. In the Unix file system, there are 9 bits of permission information associated with a file that control read, write, and execute access for the owner of the file, for owners group, and for all others. Thus, a 3-digit octal number is convenient for specifying the permissions. Yeah, 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 yeah. There are three things that tell about the permission, about the reading capabilities for the file, the writing and execution of a file, and these are divided into user, owner, and the world. Right? User, owner, and the world. And so yeah, these three possibilities can be defined by numbers, like from 0 till 7 in the octal. It specifies read, write, and execute permissions for the owner, and read, write, execute permissions for the group and everyone else. To illustrate, here is a simplified version of the Unix CP, which copies one file to another. Unix CP, which copies one file to another. Our version only copies one file. It does not permit the second argument to be a directory, and it invents permissions instead of copying them. Error. What does this do? If argument is not 3, error usage C from and to. CP, then from, then to. If f equals 1, open argument this equal this, error CP can't open file. While I'm getting the buffer, what do? I write it at some place from F1 to F2. This program creates the output file with the fixed permissions of 0666. With that stat system call described in section 8.6, we can determine the mode of an existing file and thus give the same mode to the copy. Okay, note that the function error is called with variable arguments, like much like printf. The implementation of the error illustrates how to use another member of the printf family. The standard library function vprintf is like printf, except that the variable argument list is replaced by a single argument that has been initialized by calling the va start macro. Similarly, vfprint, vsprint match fprintf, and sprintf. sprintf. What the heck is vprintf? Shit, I feel sleepy already. There is a limit for about 20 on the number of files that a program may open simultaneously. Accordingly, any number that intends to proceed many files must be prepared to reuse the file descriptors. The function close breaks the connection between a file descriptor and an open file and frees the file descriptor for use with some other file. It corresponds to fclose in the standard library, except that there is no buffer to flush. To termination of a program with exit or return from the main program closes all open files. The function, unlike char, removes the name from the file system. It corresponds to some library function. Remove. Rewrite the program of cat from chapter number say 7. Read, write, open, and close instead of their standard library equivalent. Perform experiments to determine the relative speeds of the two versions. Yeah, random access lseek gives me the last. Input and output are normally sequential. Each read and write takes place at a position in the right file descriptor after the previous one. When necessary, however, a file can be read or written in any arbitrary order. The system call lseek provides a way to move around in a file without reading or writing any data. lseek given the file descriptor, offset, and origin. From this origin, take this offset and give me something, a number. Set the current position in the file descriptor. This is there to set the current position, not to give me the current position. The location is specified by origin. Subsequent reading or writing will begin at that position. Origin can be 0 and 2 to specify the origin can be 0 and 2 to specify the offset is to measure from the beginning and from the current position or from the end of the file respectively. For example, to appear to a file, the redirection this for A or F open seeks to the end before writing. This appends, yep, seek to means end, at end have zero buffer, zero difference, just add to the end. To get back to the beginning, rewind. Seek this, notice the 0L argument. It could also be written as L0 or just as 0 if I seek is probably declared. If L seek it is With L seek it is possible to treat files more or less like arrays at the price of slower access. For example, the following function reads any number of bytes from arbitrary place in a field. It returns the number read -1 on example or an or error. Now this is going to be the last paragraph because I will sleep if I do not start doing any problems. The return value from lseek is long that gives the new position in the file. Lseek gives me the new position of the file, okay, or -1 if an error occurs. The standard library function fseek is similar to lseek. Fseek is similar to lseek except that the first argument is a file descriptor and return non-zero for an error. All right. We are doing day number 2015 and here we were implementing the RFC. Yes, we had implemented till now and we had to move forward. I will go in git checkout 2015 git status. Nope, not day 1. cd. What day is this? This is day 4. Yes sir, this is day 4. cd day 4. Fucking hell, I stashed the thing, right? Git stash pop. Yes, it is because I stashed the thing. I stashed it. Yes. Git day 4 ls. Yep, I have all the code in here. Go back. What is the thing that I stashed in day 3? Oh, the out function. That is okay. cd dot slash day 4 ls and part1.c. Add padding function works, right? Add length function works, right? I have added padding, I have added length, I have defined 4 functions which they told us to define, and then a function that would fill the sign table, and I also have the sign table at some point. MD5 algorithm. Yep. Let's say yep, I have done till this point. Now we first define our auxiliary functions that each take as input 3 32-bit numbers and produce an output 132-bit word. Yep, I have defined these functions. Yes. Now this step uses a 64-bit element table constructed from the sign function. let let ti denote the ith element of the table, which is equal to the integer part of this times absolute value of sign this, where I is in radians. The element of the table are given in the appendix. Let's see the appendix. This appendix, I want to see the value of the tables. S11 equal to 7. Whoa. Not S but T. Give me what is the value of T things. Okay, it does not seem to be here. Okay, I'll just go back and start implementing the program. Yep, I have 3 words also which are equal to these, right? Yes. And now after that, okay, the elements of each process each 16 word block like this. Okay, 16 words mean I have to process for not let int I equals, okay, int number of 16 word blocks equals length string dot len divided by 512. Yup. Printf number of 16 word blocks, that should be equal to 1 in our case. Number of 16 word blocks. Clang part1.c /out. Yes, and I do not see a few things. Okay, I printed the table while I less than length and I starts at 0. I do print x dot length string dot s I plus plus. Yes, that is correct. And after that I can delete that. ls and part1.c print length. Yes, fill the sign table. Yes, after filling the sign table, I'm not printing the sign table. Clang part1, send it to /out. Now I should see it, and yes, I do see it. I do fucking see it. After printing the link, I print this and do this. Clang /out. Wait, that was stupid. Yes, I am printing every element, so I should not do that. Instead I can do put char, put a new line there, slash out. Yo, number of blocks is 0. Fucking hell. 16 into 64 into 8. What is 64 into 8? 512. Yo. So in here I have this. I can multiply the length by 8, get the number of bits, or I can divide this by directly by 64 to get one block, right? Yo. Now for I equals 0, I less than number of words of block, I plus plus, for every 16 word block. Here is what I'm going to do. And there was one more thing, the end thing. Yep, at this point the resulting message after padding, at this point the resulting message after padding with bits, with with b, has a length that is an exact multiple of 512. Yes, equivalently this message has a length that is an exact multiple of 16 32-bit words. 16 words. Yes, 16 words. And let mn denote the words of the resulting message. N is the number of words there are, that is 32-bit. That is, if I were 32 bits, yes, 32 bits, that is 4 byte of characters. How many words there are? Yes. Gracias. N is how many words there are. Now for n, for every 16-bit block, here is what I'm going to do. Here is what I am going to do. Yep, 2, like it will go up to become equal to this thing. Do copy block I into x. What do you mean block? The whole block I into x, and go from j. For every word in that block, do this, set xj copy block I into x. Okay, I am getting every word from I, from, okay, I'm getting every word for the current block into a separate array called j. And how am I getting that? I'm getting I multiplied by 16, because I have to jump by 16-bit blocks, and inside that I have to get the jth block. Okay, I got all the words in the current block at some point j, and j I represents the ith word in that block. Now save a as, okay, I'm saving a, b, b, c, c, and the original values of a, b, c, d are saved in these things. Now there are going to be a couple of rounds. Okay, let me do this much. I will copy the values. Well, I have the values. Okay, I'll just do this. A equals 0x 0 1 2 3 4 5 6, and then and bb equals 0x 6 7 8 9 9 a b c d e f. What? This one goes up till 7, and this one does not. Yep, int cc equals should be 0x 8 9 f, and from f it goes f e d d c b a 9. 98, right? Yep. And int dd equals 0x 7654321 and a little 0. Okay, I've done that. I want to copy the elements of the block in some array, right? And then let this denote this thing. Okay, this denote this thing. Okay, the following, do the following 16 operations. Okay, I can define round 1 operation, round 2 operation, round 3 operation, round 4 operation. And perform. Where am I using x? Oh, x is in there. I'm using the sign here, the function here, and a comes from here, b is here. Where is c and d? C and d have been passed in here. Okay, okay, okay. Yes, for that is okay. For every block, say how is this array, 16-bit array, going to be 16-word array, going to be it will have 16, let's say int, it is going to be character array x, character array x. How many characters will it have? One character is 8 bytes. I want this array to hold fucking hell, I want this array to hold 16 words, right? 16 words, and one word is of 4 characters, so 4 into 16, which is 64. It will have 64 elements. And now when I am in here, I have a word for myself, number of word. How do I isolate that word? All I need to do is store that word in x. How do I do that? For int j equals 0, j less than 64, j plus plus. I just go through and num, go through the length string, and x j equals length string number of blocks. Each block will take me up 64 characters, number of blocks plus j. Length string dot s. I should have that now. In x I have the words. Now I need to define these functions, this and that. This and that. Yep. And how do you do that? I'll just call this. What will this return? What the fuck will this function even return? Shit. Here, what are a, b, c, d and I? A, b, c, d are 32-bit integers. Right. Everything is fucking roaming around. A, B, C, D are 32-bit integers. Here I am using integers, and there I am not using integers. There I am using characters. Am I comfortable with that? Am I comfortable doing that? Wouldn't it be much fucking better if I were to use raw binary things in here instead of representing them as characters and stuff? Um, at this point, I have written all the functions which adhere to this code. Yes, do I want to convert them into binary, into, yeah, I can do that. Yes, I can write a function that will take in a string. Yes, I can write a function that will take in a string and return the length of it. And this is okay. This is fucking okay. This is okay. This is okay. Right? Yes, this is okay. Now, what will this return? This function has to return a 32-bit integer. So this will return an integer, and I will call it function 1. And it takes in a lot of things: integer a, integer b, integer c, integer d, which are global. So which are global. So I do not have to do this. I can access their values globally since they are global. What are the other? There is k. What is k? K goes in as the index for x, so it is going to be an integer. And then I have integer I, and then I have, what is s? S is also an integer. It is the amount of shift. Now what do I have to do is, I have a, b, c, and d. Now I have to call the function f on b, c, and d. B, C, and D. Function f is the first function in the thing. Yep, here. Function f. I'll just copy all of these, print them here. Oh, yep. Function 1. I have function 1 takes in 3 integers and returns them. Okay, now integer func1 out equals func1 with what values? With b, comma c, comma d. Is there any error? Yes, there is an error. Make this b, make this c, make this d to get the global values. Yep. I get that function 1 out. And what do I want? I have a. Yes, I want to have xk, so I also need x. X is a string, character pointer x. I want x. Inside x, I want the kth word. Okay, I want the kth word. So k0 means 0th word, and k1 means 1th word. So k equals k multiply equals, I have to multiply that by 4, because each character in k, it takes 4 characters in k to jump 16, to jump a whole word. Now I need integer word equals 0. It starts with 0. For int I int j equals 0, j less than 3. This is like so fucking stupid, but okay, it works. J equals 3, j plus plus, and what am I going to do in j plus plus? I am going to do word equals word into 10. Nope. I have to left shift the word. How many bits? 32. Nope, that is the whole character. 8 bits. Left shift the word 8 bits, and after left shifting it 8 bits, add the current kth character, the character from x, the current character, which is k plus g. Right. I have the word as an integer now. I can work with that. I got the word, and now I want ti. T is sign table. Nope, not dot, but ti. Integer sign equal this. And what do I have to do right now? I have to add all of them and left shift the thing and add b to it. Fucking hell. Okay, now add all of them. No, for m left shifted value equals a capital A plus capitalist plus function 1 a plus function 1 out plus x, which is the word, plus sign, and left shift by s amount. Right, I have the left shifted value. Now I have to add b. Int final answer, final int out equals b plus left shifted value. Return out. Yo, that is the implementation for that function. And I have to call that function multiple times from in here. Oh, I can call this, instead of function 1, I can call this round 1 function, and also define it at the top. Here now in here I have to call it returns, and fucking hell, it does not has to return anything. It can just update the value of a. Fucking hell, it has to update the value of a. Does not mean a means what is at a's position. Fucking hell. Yes. So it will have to take whose value am I updating? I am updating a's value, so I will take an integer pointer as a and integer b and integer c and integer d. Right, and this will become b, this will become c, this will become d. And when am I using a, replace this with go to a and do not output anything, do not output anything, do not return, just write void here, and in here I do not need to do that. I can do just star a equals go there and equals out. Right, is that correct? Nope. Use b here, yep, that seems correct. Let me copy this, update this with that, and then line this. Let me call the function. I will call this, not I will call this, it is called round 1. Round 1. In round 1 I have to call a round 1 function fucking multiple times. So how do I do this? First this, then 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 this. This is the way. This is the way. This is the way. Okay. That is the way that I have to call all of these functions in the round 1 function again and again. Can I give in a loop? I guess I can write a loop for this, which is going to be, which will run 16 times for int, let's say, I don't know, okay, l, int l equals 0. No, I can use int j equals 0, j less than 16, j plus plus. Right, oh, shit, why did I use the mouse? That is fucking stupid of me. Okay, yes, this takes in a character pointer, that is cool. Now I have to call round one function again and again and again. The arguments depend. Okay. Well, easily I can see that the last argument is going to be j plus 1. The second last is going to be j, and the one before that is going to cause a problem. Okay, no. I can do int pointer A, right, and integer B in pointer A, then int B comma C comma D, right, and in, let's say first, which means the first number, and all of these depends on which column I am in. And how do I find out my current column? By dividing. Well, I have to be doing the same thing. No, slightly different, but the values for these will be same. These will change. Okay, that is just fine. I can implement them right there, right there, right there, right there, right there. Fucking hell. Shit. That only the last argument adheres to J, and all of the others depend. I can do this. All the other arguments depend on the value, on the number of columns. So int column equals J divided by floor division divided by what, 4, right? So if J is 5, no, yes, no, yes, okay. Now I can do a switch of sorts, and instead of doing this I can directly write this here. Case 0. What do I do when it is 0? If it is 0, then A equals address of A, capital A, right? Yes, that is absolutely amazing. And B equals B, C equals capital C, D equals capital D. I have that. And now first will equal to 7, and second will equal only the second one differs. Second will equal to 7, and the first one depends on the number of function calls that this is. So this will become J, and this will become second. Yep. And then break. Now case 1, when it is 1, then A gets the address of D, okay, and B gets the value of A, okay, and C gets the value of B, okay, and D gets the value of C, okay, and second becomes 12, and then a motherfucking break, right? And now case 2, ladies and gentlemen, but there have been a mistake. This has to be like this. And now case 2, A gets the address of C, okay, and B gets the value of D, okay, and C gets the value of A, okay, and A B C D gets the value of B, right? And second becomes equal to 17, and then I break. Now case 3, which is the only remaining case. Here A gets the address A gets the address of B, and B becomes equal to capital C, and C becomes equal to capital D, and D becomes equal to capital A, right? And second becomes equal to 22. Now I can given all the arguments A, comma B, comma C, comma D, comma nothing. Too few arguments. What the fuck? What else? Oh yes. Yes. There are a few other A, B, C, D, K, I, S, and a character string. Yo, which is X. Yo, and 1 minute. Yo, hmm. Shit, frames have been dropping. Yes, I am live. Everything is okay, right? Well, not like everything is okay, but let's see. Yes, I am live. That is cool. Stream number 12. Yes, is that the correct way? Will this call this function multiple times on this word, on this specific word, on this specific block? Yes, I think it should do it actually. Let me see if it clangs. Yes, it does compile, so that is cool. Now this was for round 1. Now comes for here round 2. Round 2 here, this function denotes this thingy. Let me do round 2 function. This takes in the same things. I can actually copy and paste most of it, and instead of 1 I gotta change this to 2. And what is the definition for this function? What the heck does the function do? It does something like this. It does this. Okay, function, this has to change to 2, and this has to change to 2, and it will become 2 in here. Okay, I got the output for function 2, but are the arguments same? B, C, D. Yes, B, C, D, that is correct. And then K becomes K into 4. Is that correct? What is K? K is the index in X, inside X itself. Wait, K, how many elements does X have? X has 16 elements. Yes, X has 16 elements, and I have divided. Yes, X has 16 elements, and yes, I have 4 times more. Okay, that is good. Now I got the word by this. Yes, I got the word. Probably, maybe, probably I got the word in here. And then what did I do? I got the word. Yes, I got the word, and yes, I got the function output, and teeth I sign I got sign. Okay, left shifted value, I have to add a, the value at a, and I have to add the function to output. Yes, I added that. I added the word, I added this, and I left shifted the thing, right? And then I have to add b here also, and there also I added b, and this, yo, yep, that is absolute totally correct though. We'll go to the top, define this here, and let's see, how do I have to call this? Go up a bit. Yep, in around 2. I have to call the function like this. Function for round 2 like this many times. Tab, 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 tab. Okay, yes. Now let me copy the way that I called it here. Yep, that is the loop. And then I will do the same thing here, but for every loop. Yes, for the first loop, yes, yeah, these values, the values for a, b, c, d remain the same, but other things change. Yes, the second argument changes. And what the fuck, this is a retarded way for the first argument to change. How can I do that? This is actually a retarded way for the first argument to change. Is there a pattern? 1, 2, where is 3? 3 is just roaming around here. Okay, for z, the first argument, what does the first argument mean in the function itself? The first argument here in this k represents k, the word. So it ranges from till 15. Well, this will be 5, and this will be 9, this will be 14, this will be 20. But the first argument is changing like a bitch. How do I do that? Do I have to create a fixed state switch statement? How are the other arguments in the other? Okay, it is again changing like retards in all those other tables too. Either I can manually type it for them, my stream got stuck. Let me fix that. Yep, that's the way. There we go. Transform, fit to screen, and do this. Yep, I am visible now. So here the thing is that this number, for every function call, this number is changing like a retard. This appears to have no pattern, so I cannot write a loop which will do this Wait, there seems to be a pattern. In the last row it is 0, then it is 4, then it is 8, then it is 12. Okay, and in here, this add 4 plus 4 plus 4. In here I added 4. If I add 4 to 15 I get 3. If I add 7 I get this. They are at an interval of 4. But does that help me? 1, 6, I add 5, I get there. I add 5 to this, I get here. I add 5 to 11, I get here. I add 5 to 0, I get here. I add 5. Okay, 5 plus 3 starts from 5. If I add 3, I get this. If I add this, okay. So I can write a function which will give me an integer. Give next param. It will take in an integer x and return x plus and another integer increase f plus x plus increase. If this is greater than 15, then I do something else. I just return x plus increase. But if it is greater than 15, what do I add? If it is greater than 15, then I do, if it is 11 and I add 5 to 11, I get 0. So I have to do x plus increase minus 15 minus 1, right? Yeah. X plus increase minus 15 minus 1. Yo, yep. That should work. And before I do this, I'll do int second equals second for the this. It starts with 1, right? And not second, this is the first argument. First equals 1 and second always here, cool. And then first equals, not first, but I will copy the prototype, write the prototype up there, right. Yep, here first equals give next param which takes in first, and increase for this is 5. So instead of j, here comes first. That with that done, I can move on to writing function number 3 for round 3. Copy this, round 3, yo. And this I guess has to be 3. This also will be 3. This also will be 3. And let's see, this is the implementation for the third function. How is it? Yes, I call the function 3 h function on this. That is what I need. Then I get the word, right? And I get the sign, I add them all, I add A and I left shift S number of times, then I add it to B and I put it equal to the A. Okay, and yeah, I can put that up there now. Yep. Now just like 39, just like this, I can call round 3 and this is just retarded. Okay, and here, yep, copy that, paste this here, 1 2 3 yeah, and the first starts with 5 and here everything is, well, and some things will change, but the increase here is 3, right? And the second argument in the first row is 4. Oh yes, I will also have to change the third argument, and in the second row it is 11, and in the third row it is 16, and in here it is 23, and this is not simply x plus I, this is 0 has to mean 33, so x plus 33, and in the above case 41, here 0 has to mean 16, I guess. Let's see. Yes, it has to mean 17. Okay, and anything else? Nope. I call it the same way I did the last functions. Now after function number 3 comes, this is getting too clogged up. This has to change to 4, this also changes to 4, this also changes to 4, and this also changes to 4, and what else? Nothing else. Yep. Let me copy the function implementation, the function specification for round 4, paste it here, and see, yep, I have function. Okay, and go up, copy this, paste this, and now do the rounding. Round 4, copy and paste these. Now tab and tab and tab, and here also tab, and come into this, all of this out, and first it starts at 0, right, and the second is 6 in the first row, and then 10 in the next, and then 15 in the next, and then 21 in the next, right? And how is the increase? Increase is of 7, right? And here I have to add 49, it seems. Fucking hell. After round 4 has completed, what do I do for each word block? Then perform the following addition. end of loop in I. A equals A plus A equals A plus A, B equals B plus BB, and C equals, I think I'm going to mess this up like completely and never be able to figure out where I messed up. After doing that for all of them, the output, the message digest produced as output is ABCD. That is, we begin with the lowest order byte of A, lowest order byte of A, and end with the highest order byte of D. We start with the lowest order, I have to flip. Let me just, at the end of this, printf %L %x %x hexadecimal values. And what are these? These are A, B, C, D. Error. Okay, no error. Whatever. That answer seems to be the answer. That thing that I'm getting at the end. They are telling me that this is the answer. Okay, now the test. For this, I should get something like this. Can I look at it? It is. Wait, I got somewhat the same thing that I got in the last one. Why did that happen? Kind of similar thing that I got in the last one. Why? Let me stop printing everything else. Yes. Stop printing this. And yeah. Clang ./out. Okay, that is totally fucking out of bounds. That is wrong. Where could I have messed up? Where the fuck could I have messed up? And why are both of these same? Why are both of these same? Why are they same? I'm giving in X, right? And here I am getting the word. For the round, console.log, is the word fucking 0 for every time that I do this. I left shift it and add the new value. Wait. I am adding one character. Only, which is okay. Which is okay. Yeah, let's see. Not console.log, what the fuck. Printf percent d new line word. Now what should the last word be according to this? I called the function last time for this, but and here 12. No, I'm doing this for round 1, so 15. I should get the value for the last word, which should be 0. Let's fucking do it. And 0 all the way. That is wrong. So I have figured out the problem, I guess. It is with the way that I am calculating the word. Word equals word plus word, shift word to left and add to word the k plus j byte. Yeah. K plus j. This should fucking work. This should work, but it does not. Is x not good? Am I messing up with x? Where am I calculating x? I am calculating x here for every loop. Let me do printf percent s and then let me give an x. Okay, that didn't do anything. Wait, this is not working, I guess. The whole problem lies with this simple thing. Yes, I have the dinosaurs. I got this. I have the dinosaurs on my side. Let me print it manually on my own. Oh, I got this. Extend this up in here. Extend the courtesy. Put xj. Clang / out. Okay, and no, nothing. Okay, so there is some problem with that. I didn't get to see anything. Let me put an h. I should at least see a bunch of h's. Yes, I see a bunch of s, h. I don't see a bunch of s. Yeah. Put this to the center and xj. Seems to be it is 0. Why is it 0? Number of blocks is wait. This has to be I. Okay. Now some values are good, some are not good. This is what I got for x, which is, what did I get that? A B C D E F 609. Wait, what is that? Yes, A B C D E F 609 043 9043, and after that some unknown values. That is cool. That is cool. That is cool. And a number. Okay, that is cool. That is cool. So this should have outputted 6090. The answer is 60904 6029. The hash function is not hashing, and this starts with 5 zeros. The hash for output for this starts with 5 zeros, but mine is not starting with 5 zeros. Why? Well, first of all, I'm not printing the output in the way that they told me to print, but still I should have seen some zero somewhere in somewhat correct order, at least in the first 8 bytes. But I don't. I see 6136 EF 6136. Is there any 6136 6136? Is there any 6136? Nope. Trying to see things that aren't there. This oh, 1 dBBFA. Nope, not even close. 1 dBBFA. Nope. Why? Fucking hell. Because when I am converting inside the functions, when I am converting the word into an integer, I am getting this. Nope, that is not what I want. I want to use something. Is there a way I can use how to use a 32-bit value in C, which does not act as an integer, unsigned integer? Yeah, unsigned integer is cool. Signed, nope, unsigned 32-bit int. Unsigned int. Unsigned int. This is an unsigned int. Okay, you hear me? Yep, this also is a unsigned integer, and here also. Oh no. And 1 5 paste, copy. Wait, what the fuck did I do? Unsigned integer and unsigned integer. Right, that is also unsigned, that is also unsigned, and that is also unsigned. Now I hope, can I even hope? Nope, I cannot hope. I said that it is unsigned, and still I am seeing negative values there, because I'm treating the answer as an integer. Okay. What I can do is, yes, I can do a crazy thing. I can do this s and replace every signed int with a single int global, right? And then I can do change every int with an unsigned int. That would be actually awesome. For also I will do type def unsigned int as u int, right? Percentage s comma int. Okay, how to replace text in vim after the cursor for the whole file. In vim, to replace the text after the cursor for the whole file, you can do this. Explanation: this starts from the current line where the cursor is. This means continue until the end of the file. This means at the current line, right? Yep, this means at the current line, and this means that, and s. Now make it okay. Type how to make it case sensitive. Yes, how to make it. By default it is case sensitive, however I can do C and this C int s. Now it is, wait, is it okay? No. I'll fix that later. Fills int. Okay, percent s fills int percent s change sign table with sign table, right? Are there? Yes, there are. Oh, print. Okay. Why is this non-void? Oh. Why is this non-void? Oh. Are there any errors in the file now? No. I will see a bunch of errors. Okay, I don't see the errors, but this should not work. how can I fix that massive fuck up, like changing everything in the file kind of fuck up. Yes, it is just fixed. Dot slash out. Alright, I am not getting the correct way. MD5 hash C library C. Is there a MD5 hash function? How to create MD5 hash of a string in C? Is that it? Void MD5 init, MD5 update, MD5 final, MD5 transform. Unsigned int. Yep, unsigned int. Structure. I don't know this particular, but I use. Okay, so there is md5.c library. Like there is this. Okay, so seems like I will have to change all of my code writing from unsigned int to signed int. From a normal integer to unsigned integer. Okay, I was too stupid to know it in the start. Length as an integer is okay. Now all of these functions, these two, they do have to be fucking hell. Let me define a type def, which is this type def unsigned int will be called uint. Okay, and this belongs to the type uint. This also belongs to the type uint. This also to uint. This also to uint. This also to uint. This also to uint. This also is uint. This also is uint. And now all of these, bruh. Uint. Make all of that like that. Is this necessary what I'm doing? Yes, it is goddamn fucking necessary for the survival of the humanity. Yeah. And where else do I have to change it? Yep. In function definitions below, I will have to change it. I can just copy one of these and I will paste it below later down inside in here. A has to be an unsigned int, and B and C and second can also be unsigned int. Not can, but they have to be. Same thing goes with you. Yo. Same thing with you. Same here. Same here. Right. Now the function definitions, these are fucked up. What the fuck up? Yep. Pripyat. What is Pripyat? F1, change that by 2. Yes. Go to line number 15, do the same there. F2, change that by 3. Go below and down under. Yes, change that. Move, make this 4. And here, fuck. Inside every function, I have to change stuff. Inside every one of these functions, this will be unsigned. This especially has to be fucking unsigned. This doesn't have to be. This is okay as it is. This has to be unsigned. This has to be unsigned. This has to be unsigned. Unfucking signed. Everything. This has to be unsigned. This also. Let's make everything assigned. And even after that, I don't think I will get this right. And I will have to start implementing this function from scratch. Okay. Error. Bus error. Okay, I see a different number this time at least. 14BB. Is that anywhere close? Well, I see BB, FA. What do I see for this? Wait, where is the part there that I was printing stuff? In the first function? Yep, in the first function. I see the out. Oh, okay. Wait, then 39. Remove that. Okay, that is the answer. When the secret is something like this, and now if the secret is something like this, then the answer comes out to be this, which is just nowhere fucking even close to this 6136EF. Nope. Is it the way that I'm printing it? Is it the way that I am printing it, or should I process them as binary? Should I process them in their binary form? Should I process them in their binary form? So if the mistake lies in printing, then I have 5 zeros in here and 5 zeros in here. Therefore, at least some of these characters must match. Are they matching? At least somewhere at some point. Nope. Wait, frames are dropping. I do not want to open my stream and check, because that just makes more frame dropped. MD5 hash calculator for this number. MD5 hash. Let's see. This is my thing. Generate the hash for this. The hash is this. SHA hash is this. So okay. So my implementation is wrong. Of course, my implementation is wrong. I think the whole thing is happening inside of these functions. I'm messing up inside of these functions, right? A, B, C, D are 32-bit unsigned binary integers. Yes, yes, yes. They are 32-bit unsigned binary integers. I add B plus, I add B plus the left shifted value. What is the left shifted value? Left shifted value is the value at A, right, plus the function one out, right, which takes in B, C, D, the word, right, the sign, right, and then the shift, right. Is the sign table wrong? Is the sign table wrong? Sign table starts from this represents the number in sign table. Wait, what? No, this is the value of k. Wait, what? KSI, KST, KSI, KSI, KST, it's K and T. Hey, what? I do not have any KST in here. S and T, I do not have any S and T here. I have S, but I do not have any T in here. Any small t in the equation, but they have given me t here. Okay, okay. Si is here. Si, K, S and I, K, S, T, K, S and why is this T? Where the fuck is that T? Does that T needs to be replaced by I? Okay, I'll just go to the washroom and come back in a minute. Yup. Mm-hmm. This does not. Mm-mm-mm-mm-mm-mm. Yes. So I think the sequence of things changed a bit here. At the end, I'm doing this. I'm doing everything with that. Oh, this has to be equal to this. Oh, God. Fuck. Was that the thing that I was messing up? Was that the thing that I was fucking messing up? Okay, I have to do this at the start of every loop. Well, there. No. Okay. I will do it. Fuck. What do I have to do now? Yes, I have to do AA equals A, BB equals B, CC equals C, DD equals D, and I don't think this will help me. Help me. And at the end, I'm adding let me check the function definitions. Not the function definitions, but the way that I'm calling the function. In the first row it is ABCD, then in the second row it is DABC, DABC, ABCD, yes, and then it is CDAB, CDAB, yes, and then it has to be BCDA, BCDA, yes, that is correct for round 1. For round 2 it has to be ABCD, yes, basically the same thing, and I copy pasted, so all of them are correct. Now oh okay. S comes before I in function definitions. S, I have A B C D S, and then I have to take in S, replace this by S and replace this by I. Fucking hell, if that was the problem, then we got some real problems, because that is too stupid. And wait a minute. That should work now, I guess. Clang dot slash out. That did not even is it even kind of close? What is the secret? Secret is this, right? Second one. and nope, it is not even close. It has to be 6 1 something. 6 1 EF. Ah, fuck. I think the problem might be with right the after this point. Okay, let me print int I equals 0, I less than linked string dot length I plus plus put char length string dot s bracket I, and the end put char new line, or to be crazy I can give it 10. Okay, that is wrong. That should not happen. No, that can happen if I'm trying to print hexadecimal values. Yep. Let me try to print hexadecimal values. Printf. No. Instead of put char and going it till the length. What does length mean? What does length? Length is the number of bytes, right? And 1 byte is represented by 2 hexadecimal values. Right. 1 is represented by 2 hexadecimal values, right? So therefore I'll do this printf percent %L no %x means hexadecimal, and I should see the hexadecimal value for it, and this is it. Is this nah, this seems very small than how it should be. This seems really very small than how it should be. Oh, there was an E here, and E at this point means that I have added the length. The length of the original message was, wait, what? The length means the number of characters in the original message, or what does length mean? What is the meaning of length? B, yes, the number of characters in the original message. So this had 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14. E is 14, and there are 4 bytes in here. Yes, that is correct. That is absolutely correct, the way that I have added the length. I guess the problem might be with add padding, the way that I am adding padding. Bits equals to I into 8, that is the number of bits. I got a remainder remainder bits, right? Padding bits equals 0, and padding bits, if remainder is less than 448, then padding bits equal, I have to make it equal to 448. Yes, so I do that. Else if it is greater than 448, then if it is greater than 448, then subtract. Yeah, what the fuck is this? That is not the right way. The right way is minus 448. It seems. Like that, it did not change a damn thing. It should have. Wait, how did I go to the function? Yep, like that. That is just crazy. Fucking hell. Yes, padding added. Padded. I plus 18. I is the number of bytes. Yes, I is the number of bytes. And then I did remainder minus 448. Because remainder is greater than 448, so I need how much greater it actually is than 448. Add that many bits, and then this. Got a character array of I plus 18. Due to some reason, I plus 18. Why have I gotten I plus 18? What are those 18 extra bytes? Okay, but still after that I do index equals 0 and I equals 0 secret. I go through the secret. Till I see the end of the secret, and what do? I copy all of them, right? I copy the secret exactly as it is in the padded answer, and I calculate the number of padding bytes that I have to give. Oh, is that correct? Should I always get this here? Let me at the end print this again. Bits. How many bits were there? There were 112 bits. 112 divided by 8. Mm-hmm. 14. Do I have? Yes, I do have 14 characters there, so that much is okay. Then I need to add 336 padding bits. So 112 plus 336 is 448. That is what I want. Now index is this and padding bytes are 0. Padding bytes are 0. This is correct. This as much as I can tell. Let me ask ChatGPT. I have a string. Can you give me the padded and lengthened value for it in a It is digest MD5 hash function. What is the string? String is this. Stringo is this. String is this. Convert this into yes, ASCII 14 characters, 112 bytes. Add a single byte, 100, and eight zero. Yes, that is what I see here. 80. No, do not give me the answer. Padding. This bytes. 41 bytes. 0 to reach 448. Yes, append the original length. Can you give me the final 512 bits sequence in hex? Let's compute and display the full padded sequence. Yes, if it is equal to this, then I am a happy man. If I am a man. Okay, ChatGPT stopped. Stream is working correctly. I think I will tackle. Oh, fucking hell. Okay, there. Huh? 70308030 and then 8, quite a few zeros, and then E0. Why is there E's? 80 is the mandatory 1 byte. 0 paddings, right? And length in fucking bits. Is that what you want? You want the length in fucking bits. 70. Fucking hell. And 17 little Indian. Okay, so I see two problems here in my original thing. Adding the padding, and then adding this. So this should not be here. This and so the problem is with the padding thing. Wait, yes, padding. When is it that I am adding 1? Yep, I added 1 here. Add 1 byte here. Yeah. Why am I seeing all those F1s there? I have to add 1 byte. have added one byte here. For the padding, it see what is, okay, I can represent that in hex, right? In hex it would be equal to how much? 80. What's the shout? It is still F. Why the fuck am I seeing all these F there? Add padding, yes. Why am I seeing all of those F there? Copy this and go to the definition for this thing, and at the end I will print the array itself, not length string but till padded answer bracket I not equal to no. Wait, I will see. Will I see null? No, I should not see null. This has to be padded answer clang. Okay, it is. The problem is somewhere here only. Okay. Padding, right? Yep, padding. Let's go to the padding function. What is it doing? Let me try to print this before when I have only copied the secret. Wait, the secret is copied perfectly. The problem arises after copying the secret. Right. Yep. At this point it is correct, but then it becomes funky. It becomes messed up. Why am I seeing all those F there? Wait. 1F represents what? 1F represents 1111, and I have a bunch of them there. This thing is messing up. This is the one. This is pointing me to one byte, right? Character, yes, to one character, and I am making that character equal to the hex number 80, which is equal to a binary number. Let me just make this binary 1 1 2 3 1 2 1 2. This should not be happening. Padding width minus, and it's that. Yes. Padding whites, if it is greater than 1, Then do that. And yes, if it is greater than 1, then make the thing at this character equal to this. Okay, let me also do printf, print the character code for ob 1000, or just no 10000000. Right, right. Yep. That should show me something. Okay, 80. I got 80, but why the fuck am I getting all these F here? What is that all about? All of those F. I should not get them. And how many bytes are there? 1, 2, 3, 4, 5, 6. 6 bytes. 6 F, that is 3 bytes. I'm adding 3 full bytes there at some point. Okay, so when I am printing it here at this point, it is correct, and after appending this, it becomes wrong. Right? Yup, it becomes wrong. Fucking hell. Why is that happening? Why the fuck is that happening? Here I am, and I got the space, yes, but getting the space is not the problem. Till this point, everything is correct, and then I do this, and everything fucks up. Why? Let me do this just before the loop, just before the if, and just after the if. And let's see. Clang, pass that out. Wait. Whoa. Before the loop, I got nothing. Before the loop. Where is the loop? Yes, before the loop. Yeah. That is absolutely correct. Yes, I see one. Then I will see the next one. Let me just do put jar 10. See, yep. So that is messing things up so much. Okay, I am going to end this stream today here, and we will continue working on this tomorrow. That is it.